Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Differences Between Bananas and Chocolate by Phil the Hat. And I don't know what this reference is, but let's get to the rules. We have normal Sudoku rules, which are place the digits 1 through 9 once each in every row, column, and 3x3 box. Each cell must be shaded one of two colors, chocolate or banana. Okay, so that's where we have the differences between bananas and chocolate, I guess. Orthogonally connected cells of the same color form regions. Chocolate regions must be square or rectangular in shape. So chocolate, which I guess we'll make orange. I guess we could try to see if we have a more appropriate. Chocolate is more brown, and then we have yellow for the bananas. So chocolate regions have to be either square or rectangular in shape. Banana regions must be neither square nor rectangular. So bananas cannot be... Okay, I guess that makes sense, because bananas have to be essentially some sort of L-shaped or some other weird shape, which kind of looks like a banana, right? Just as long as it's not square or rectangular. So each cell must be shaded one of those two colors, chocolate or banana. And digits separated by a white circle must each be equal to the number of cells in its region. So that means if this were, say, if this were the only parts of the yellow that's an orthogonally connected region, it would have to be 5 here then. And then this would have to be... I guess every break of a circle, a white circle, because they are in the same row or column, it has to be a different... Well, this is kind of starting to solve things. But basically, you have to have this be a different set than this, right? Because they are in the same row. If they were part of the same region, then they would be the same amount of digits. Okay. So digits separated by white circle must each be equal to the number of cells in its region. So say this was the only brown here, then this would be 3, then in that case, if that were the case there. A number within a circle is equal to the difference between the two digits it separates. So, for example, well, okay, so this has to be two different regions, but the difference between these two cells must be 5. So you could have, say, a 4 here and a 9 here, and that would be valid. Again, these have to match the number of cells in its region, which is going to be the orthogonally connected region, which means it's basically a region which you can go from any cell in the region to any other cell in the region just by going through edges while staying within the region. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, as I said, these white lines, or white dots, have to be separating regions. Because if they don't, these would have two cells which are part of the same region, which would have to be the same number, and we'd have a repeat in those numbers, which are not allowed. Okay, so we're separating these into different regions. The only way that this works is this has a difference of 8. So this has to be a 1-9 pair here. Difference of 6. Again, this cannot have 1 or 9 here because of the 1-9 pair in the box. So this is either you could have 2 here with a difference of 8. 8 with a difference of 2. I think that's the only possibilities, right? So the 1 here is basically going to be just a 1 by itself. The 9 has to go out and then occupy 9 cells. So the 9 has to be a banana. The 1 has to be a chocolate because the 1 is a square shape of just 1 cell. Again, you cannot have 1 or 9 here. So this is either going to be 2, which is 6 away from 8, or 8, which is 6 away from 2. Or this could be 3, 6 away from 9, and 7, 6 away from 1. Those are the possibilities. Ooh, okay, so it's not as restrictive as I thought. This has a difference of 5. Difference of 5 here. That doesn't help too much. Chocolate regions must be squares. Or rectangles. Two is always going to be chocolate because it's always going to form a rectangle. 7 is always going to be banana. Difference of 5. No 3 and 8 here. So you could have 4, 9, no 3, 8, 2, 7, or 1, 6. Obviously no 7 here, so no 2 there. For a difference of 5. And you could have 1, 6, 6. Okay, so 9, 4, and this would be 3 or 5. That's possible. 7, 2. That would be 1 or 3. 6, 1, and then that would be 2. 4, 9, and then that would be 8. 1, 6, and that would be 5 or 7, but it can't be 7 because of 7 in the row. Okay. This has a difference of 3, difference of 2. So this cannot be 8. Okay, so again, we have 4, 9, 3, 8. No 8 here, so no 3 there. 2, 7, or 1, 6 here. That doesn't help too much. One and 2 are guaranteed to be chocolates. 3 does not have to be. 3 and above does not have to be. 5 is guaranteed to be banana. So is 7. 9 could be a 3 by 3 square. Okay. So 5 and 7 are guaranteed banana. But that's only if it's next to a white circle. Okay. Hmm. Hmm. These are obviously all different regions. Hmm. Remaining digits of row 1. We have 2 through 8. This can't be 8 because of 8 in the box. This can't be 6 because of 6 in the column. No, 7 because of 7 in the column. I don't know if that's helpful. 2 would obviously have to be next to a 9. So then that would force that to be 1. The 9 here has to get out somewhere. Can't be part of that. So it would have, if this is 9, so if this is 9, it cannot be same region as here. So it would have to go here. So this is always going to be banana. Because it's part of the 9, which the 1 is a chocolate. So it has to be a different set than the banana. And therefore the 9 has to be... right. So if this were 9... If this were 1, this would have to be... this would be a chocolate, and then this would have to be a banana. If this is 9, this would have to be banana, and this would be chocolate, and this would still have to be banana. Because the 9 has to get out somewhere. Let's draw a border around the entire grid. Well, we don't really need that necessarily. It's just more of a... yeah, we don't really need the one around the entire grid. These are just helpful to differentiate. So these two, this is going to be part of the same banana as 9. So this cannot be banana. It must be chocolate. Because if it were part banana, it would also have to be 9 in size then to match this. So this is chocolate, which forces this to be banana. So this can't be 1 or 2. It's 8 or 9. And that's 6 away from 2 or 3. So then chocolate has to go here. So we don't need that. So it's 2 or it's 3 this way. That means banana has to go this way for the 9. That means this cannot be banana, chocolate, banana, then since this would be part of the same orthogonal region. So this has to go banana, chocolate, chocolate. So the chocolate has to be at least 2 in sides. It's a rectangle or a square. It has to be a rectangle here. These have to be different than this. So this must be banana, which makes this chocolate here. So this has to be size 9, since it matches the region size. This is 1. This is 2 or 3. We're not sure which. This is 9, which is 5 away only from 4. So no 4 in the box. This can only be size 7 at most, so this cannot be 8. We have 1, 2, 3, 4, 5. Okay, so then this is done. This is done. This is size 4. It cannot be part of the same region as that because they are in the same row. So this must be banana. So this is size 2. So this is size 2. That's 6 away from 8. That eliminates 2 in the rest of the box. So this must be at least a size 3 chocolate. This is size 9. This is not a square or a rectangle. 8 cannot be here. 8 cannot be here. Where is 8 in box 1? It must be one of those two. 8 has to be one of those 3. This is either going to be 4 as a rectangle or 4 as a square. We're not sure which. These are both 2. So it cannot be, it has to form a rectangle, so this must be yellow. These cannot be the same region because this is size 9 and this is size 8, so we must have a chocolate there. These cannot be the same chocolate because it's not going to form a rectangle or square. So this must be banana here. So this is size 4 as a chocolate, which means all of these are bananas. Okay. This is already 1, 2, 3, 4, 5, 6, 7, 8, 9. So the rest of this cannot be bananas. They have to be chocolate. If this is chocolate here, it's not going to be able to form a rectangle. So this is banana. This is size 5 as a chocolate, so that's 5, which eliminates 5 in the rest of the row. That means 4 has to be one of these 3. This is size 4. We have 8 here. This is yellow, and it cannot be 1. It could be 4, 6, 7, or 9. Yellow cannot be a square, so it can't be a singleton. It has to be at least these 3. This is a square, that's fine. This could be yellow here. It could be brown. One of these is yellow, one of these is brown. We're not... Okay, so this is yellow, which forces this to be chocolate. That's banana then. These have to be different. So this cannot be yellow here. It's brown. This cannot be size 4 because that would form a rectangle only. So this has to be 6, 7, or 9, which forces this to be 1, 2, or 4. That's a difference of 1 from no 8. 1, 2, 3, 4, 5. You could have brown here and then just size 1. Or it's yellow of size 5 here. So this is 1 or 5. This yellow cannot be size 1. Cannot be size 2. It's 3 or 5 here. That's consecutive with 2 or 4 here. So this can't be 6, which is 5 away from only 1. So this is size 2 or 4 as a chocolate. If this were brown, this would be a yellow region by itself and would be a square. So this cannot be brown, therefore this must be yellow, which forces this to be brown. It's only size 2, because if it goes out that way, it's not going to be a square or a rectangle. So this is size 5. Therefore, that makes this yellow. This can't be 2. This must be 4, which makes that 5 away is 9. This could still be 3 or 5. 2 eliminates 2 in the rest of the column. 4 eliminates 4 in the rest of the column. 5 has to be one of these 2 digits here, because there's no other place for it in row 2. This is brown. It's size 4. We don't know. 3 or 5. It has to go to one of these 2 at least. Size 8. Could just go down that way. This could be yellow and red, or yellow and brown. That could be the case. We don't need this anymore. We don't need this. Differences between bananas and chocolates. We have size 2, that's size 4, that's size 9, that's size 3 or 5. One, 2, 3, 4, 5, 6, 7, 8, 9, 5. So what's satisfied already? That's 1. This is 9. This is 5 as a square. We have 9 there. This is 4. That's 2. We have 8 is not done. 9 is not done. 4 is not done. 2 is done. And 5 is done. Okay. It cannot go 4 straight this way, because if it were, then the 9 would be blocked. So it guarantees this has to be brown this way, because you can't have 3 and then 1 that way, but it doesn't. That's not a rectangle or square. It's either 2, 4, these 4 here, or these 4 here. We're not sure. Oh, cannot be these 4 here, because then this is the same as that. So this must be yellow. This must be a square that way, which means the rest of the digits that share an edge must be yellow. Okay. This is yellow, which forces this to be brown, which forces that to be yellow. This could just be 3. This is either going to be 1, 2, or 3 as a rectangle. So this is done now. 4 is done. So this is 1, 2, or 3. We don't know which. That's 3. 1 would have to be 4 here, so that's not possible because of 4 in the column. So this would be 3 would have to be 6 here, so this must be size 2, which is 3 away from 5. So this must be 2 going this way. Yellow could just be 5 there. That is possible. We know one of these 3 is a 5. So these all must be yellow, because you cannot have a chocolate next to it. Okay. If this is brown, this has to go yellow that way. This cannot be 5 ever. If this were 5, it has to connect to here, but then this is already 6 size as a banana. So this must be 3, which forces this to be chocolate here. Banana, that's a singleton by itself. This cannot be 2 by itself, so it must be banana there. If this forms a set region with that, it's not size 7, and they would have to be the same digit. So this cannot be brown, this cannot be banana, it's brown. This is size 4 then. That eliminates 4 in the rest of the column. So this can't be 4. Where's 4 in row 1? It has to be here now. So this is done. We have the 4 done, the 2 done, the 3 done. This is 1, 2, 3, 4, 5, 6. This is yellow. So that forces this to be brown. Okay. Um, hmm. This cannot be part of the same region as this because this is size 5 and this is size 9. So this has to be brown. We need 5 yellows. It has to be at least here. It has one of these is yellow. The other one has to be brown. Okay. This cannot be brown, 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 because that's not going to form a square or rectangle. So this is yellow. This could just be a singleton brown. This could be a singleton brown. Size cannot be 4. Could be 1. Cannot be 4. This cannot be 4 because of 4 in the column. I think this might have to be part of the. Oh yeah, it has to. 1, 2, 3, 4, 5, 6, 7, 8, 9. So then this is all yellow, which means this must be brown. This is size 9. Oops, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. This has to be 9 also. So then these are all done. And these can't be yellow because it's already filled. Therefore, this is at least 2. Yellow has to get out, and it has to be at least 8. So these are all yellow. This cannot be... Oh, this is brown, which makes that yellow. So this has to be size 8 also, which eliminates 8 here. So this is 8 there. We have 2 more. This is brown. This is size 2 as a chocolate. So we can remove that. This is 5. We are not done with that yet. Yellow cannot be just a singleton by itself. It has to move around. So we could go that way. Remaining digits in... This can only be size 1 or size 3. Can't be 2 because of 2 in the row. So as a square, okay, so this is 8. We have 2 yellows here somewhere, and then the rest have to be brown next to it. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is size 1 as a chocolate. This cannot be yellow here because then that would connect to this part here, and that's not size 5. So this must be brown, which makes this yellow. This is all 5 yellow, so that's done. This is brown then, which makes this yellow. So that's done as a region. This is size 3 as a chocolate, which makes this 2 away. So it cannot be 1 because of 1 in the column, so it's size 5 as a banana. So 5 here is done. 1 here is done. 3 here is done. This cannot be size 3 because if it's 3, then this banana would not be able to be size 5. So therefore, this is 1 here. That forces a banana here. These are part of different regions because this is size 8 and this is size 5. So this must be brown there. This has to have 5 cells for the banana, so this must be 5 there, which makes that brown. We have 1, 2, 3, 4, 5, 6, 7, 8 bananas here. And so those are done. So we have 8 here. 8 here, 1 here, 5 here. That should be everything, right? Size 1 chocolate Size 9 banana. 1, 2, 3, 4, 5, 6, 7, 8, 9. And that satisfies both of those. Size 5 chocolate. Chocolate square. Size 5 banana. Size 4 chocolate. Size 2 chocolate. Size 8 banana. Size 2 chocolate. This is a 1 size square, but we don't have to have a circle next to it. Size 9 banana. 1, 2, 3, 4, 5, 6, 7, 8, 9. Size 2 chocolate. Size 3 banana. Size 4 chocolate. Size 1 chocolate. Size 1 chocolate. Size 5 banana. Size 5 banana. Size 3 chocolate. Size 2 chocolate. Size 4 banana. And this is a chocolate. That is a square. So the rest is just normal Sudoku. The one remaining in column 2. So let's... okay, so we don't need these anymore. I guess we could have left it. Okay, whatever. One remaining in column 2 cannot be here because of 1 in the box. Can't be here because of 1 in the box, so 1 is there. 1 remaining in row 5 can't be here because of 1's in the boxes, so 1 has to be there. We don't have very much more information there. 2 in row 6 cannot be here or here because of 2's in the boxes, so 2 is there. That leaves a 2 being here. 2 cannot be here. 2 cannot be here in box 7. Sorry, box 8, so 2 has to be one of these two, which eliminates 2 being there. So then 2 has to be here. 2 eliminates 2 from being here. Where is 2 in column 7? Can't be here because of 2's in the boxes. Can't be here because of 2 in the rows, so 2 has to be here. That eliminates 2 from being here. So, and 2 from being here. So where is 2 then in box 2? Can't be here, can't be here, can't be here because of 2's in the rows and columns respectively. So 2 has to be here, which means this can't be 2. This can't be 5 here. So this has to be 5 there. 2 eliminates 2 here, so that's 2 there. And that should be all the 2's. Oh, I forgot the numbers. 1 and 9 have a difference of 8. 4 and 9 have a difference of 5. 2 and 8 have a difference of 6. 4 and 9 have a difference of 5. 2 and 5 have a difference of 3. And 3 and 5 have a difference of 2. And the rest is just still normal Sudoku. So we have 3. 3 eliminates 3 being here. That's not helpful. 4. 4 cannot be here or here because in box 5, so 4 has to be one of these two, which means 4 in row 6 has to be one of those two. No 4 here, that's fine. 4 has to be one of these 3. That doesn't help us very much. 5. 5 has to be one of those two. In column 5, 5 can't be here or here because of 5 is in the boxes, so 5 is there, which forces this to be a 4 there. 5 eliminates 5 there, so this must be a 5 here. That gives us, where's the 5 in row 5? Cannot be here because of 5's in the boxes, so it must be there. We have 8 5s now. We know where the last 5 is. It has to be there. 6s. We don't have any 6s. 7s. We don't have any 7s. 8s. 8 in row 7 cannot, or row 6 cannot be here because of 8 in the box. These are filled out. Can't be here because of 8 in the column, so 8 has to be there. 8 in, this has to be a 6-8 pair here in row 5. That leaves this digit as a 3. Eight has to be one of these two digits here. 8 can't be here. 8 could be any of those 3. That's fine. Nines. 9 in row 3 cannot be here because of 9's in the boxes. Can't be here because of 9 in the column, so 9 is there. In column 9, 9 can't be here because 9 in the boxes. These are filled out, so 9 is there. That leaves in column 6, 9 has to be one of those two. In column 1, 9 has to be one of those two. Okay. Remaining digits in row 4. Actually, remaining digits in column 9. We have 3 and 7. That makes a 3-7 pair, which eliminates 3-7 in the rest of the box. So we have 1 and 6 remaining there. Remaining digits in row 4, we have 6 and 7. Okay. Same with box 6. 6 or 7. And this must be 4, 6, or 7 here. Um, 3 eliminates 3 here. Remaining digits of column 4. We have 6 and 7, and this can't be 8 because of 8 in the row. Column 2. We have 4, 6, and 7. And this can't be 4 because of 4 in the row. This can't be 6 because of 6 in the row. Actually, let's do box 9. We have what? 1, 8. 3 can't be here. 3 can't be here. Where's 3 in the box? It must be here. Remaining digits in this box are 1, 7, and 8. No 8 here because of 8 in the column. Okay, that seems fine. Remaining digits of row 7, we have 3, 6, 7, and 9. No 7, 9, or 3 here because of 7, 9, and 3 in the column. So this is 6, which makes this 7. This can't be 3, 6, or 7. It's 9. This can't be 6, 7, or 9. It's 3. Where is 3 in column 3 then? Can't be here because 3 is in the boxes. So it can only be there. 3 eliminates 3 here, so it's 7, which makes that 3. That eliminates 3 in the rest of the row. We have 3 in the corner. So this becomes a 6, 7, 8 triplet, which eliminates 6, 7, 8 in the rest of the box. Therefore, this must be 1 and 3, and this can't be 3 because of 3 in the column. So this is 1, that's 3. 1 eliminates 1 here, so it's 6 and 1. 7 eliminates 7 here. This becomes a 4, 6 pair, which eliminates 4 and 6 in the rest of the box. So this can't be 6, it's 7. 7 eliminates 7 here. This becomes a 6, 8 pair, so that forces this to be 7. 9 eliminates 9 here. Where's the 9 in column 1? It can only be there now. 6 eliminates 6 here, so it's 7, which makes that 6. 7 eliminates 7 here, so it's 1. So neither of these could be 1. It's 7, 8 as a pair. 7 eliminates 7 here. 6 eliminates 6 here. So this is 7. Therefore, the rest of the box is not 7. 7 eliminates 7 here, so this is 4, which makes this not 4. It's 6, which makes that 4. 4 eliminates 4 here, so it's 6 and 4. Remaining digit in column 1 is a 7. Remaining digit in column 3 is a 6. 6 eliminates 6 here, so it's 8 and 6. 6 eliminates 6 here, so that's 8 and 6. Remaining digit in column 5 is a 3. 7. Oh, wait, that can't be right. It's a 4. 3 is here. 7 eliminates 7 here, so that's 8 and 7, which leaves this as a 1 and this as an 8. And that's how you solve it. Very cool, actually. Very interesting how this worked out. I don't know if I would consider this easy per se. The execution wasn't too bad, I feel. The execution might have been easy. The logic, though, hmm. There's a lot of geometry involved, which I, to me, the geometry stuff isn't as easy for me. So maybe that's why I would consider that more challenging level versus just easy. Still, very cool puzzle. Very well done with the way that the bananas and the chocolates worked. And that restriction was actually very interesting too. Well constructed. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.